All right, BC Calc students, we are on to our first BC topic of the year. It is still in 7.1, but it is called Euler's method. Not Euler, Euler. Make sure you guys get that right. It's German. Now, Euler's method pretty much states this. Let's say you have the graph. We'll do a graph that we know. The square root of x. And you want to figure out what the square root of 4.3 is. We don't know the square root of 4.3 off the top of our head. This is obviously going to be done without a calculator. This is a non-calculator part of the AP test. We don't know the square root of 4.3, but we do know the square root of 4. And we should all know that the square root of 4 is 2. And we're going to create a tangent line at that point to help us figure it out. Thing is, from here to here, look at what happens to the tangent line and our answer. We end up getting a really, really big gap. So Euler said, well, what if I use this tangent line to help me figure out something closer, like 4.1, and then I can make a tangent line from there. And then I'll go to 4.2, and from that tangent line, I'll make another tangent line. So I'm making a tangent line on a tangent line on a tangent line. And it's not going to exactly be where it is at 4.3, but it's going to be pretty darn close. So Euler's method is just a tangent line on a tangent line on a tangent line. It is something that we have done before, so don't freak out about it. Now, the official formula for Euler's method is this. It says you're going to do f of x naught plus delta x is approximately going to be f of x naught plus the derivative at x naught delta x. Now, before you guys all freak out and be like, what does this say? This doesn't look like a tangent line. Yes, it does. F of x, or f of x naught, is just your y equals. Instead of y equals, we're going to use y approximate because I'm approximating the next one. F of x naught is your y1 plus this part here is derivative. What does derivative mean? Slope. So that's your m. And delta x is the change in x. That's just your x minus x1. But there's just saying that you're going to go by the same amount each time. So in our example here, our delta x was 0.1 because I went up by 0.1 every single time. Now, best way to do this is through examples. So we're going to do a couple examples of this so that way you guys get the chance to figure out how to do this. And do not worry, it's not too bad. All right, so our first example. Let's see. Let's say we have dy over dx equals 1 plus y. So that is our differential equation. You have to start out with a point that we know. So our example of square root of 4 is 2. That's the point that we knew. We're going to start out with a point that we know. It's going to be given to you. Y of 0 equals 1. And it says, let's say, let's just keep it the way it is. Let's say delta x is 0.1. And they're going to ask you to solve for y of 0.5. 3. So that means, how many times are we doing Euler's method? Well, if I know 0, I'm going up by 0.1, and I want to end at 0.3, that means I've got to do Euler's method 3 times. Got it? So the first one I'm going to figure out, if I'm starting at 0 and I'm going up by 0.1, that means the first one is going to be y of 0.1 is approximately. Now I'm doing my tangent line, y1. What is my first y value that I know? It's 1. Plus m. M is our slope. Slope is derivative. That's that right there. And it says to do 1 plus y. Well, y is 1. So what's 1 plus 1? 2. X minus x1. That's your delta x. And that's going to be the same for this problem. It's going to be 0.1. Well, so now I just have to figure out what this is. So this is 1 plus 0.2. 1 plus 0.2 is 1.2. So my new point that I'm talking about is 0.1 comma 1.2. That when x is 0.1, my y is approximately 1.2. Not done yet. I have to get to 0.3. But I'm at 0.1. So if I do Euler's method again, 0.1 plus 0.1, that means the next one I'm figuring out is 0.2. 0.2 is approximately. Again, I'm doing my tangent line, y1. But I'm not using the y1 I started with. Otherwise, I'll just get the same answer. I'm now using this point. So my y from my new point is 1.2 plus m, the slope. 1 plus y, now remember my y is 1.2, so 1 plus 1.2 is going to be 2.2 times x minus x1. That's going to still be 0.1. That's my delta x. So this ends up being 1.2 plus 0.22. which ends up being 1.42. So now this is my new point, is that 0.2, my y is approximately 1.42. So I'm at 0.2, but again, where did I want to end? I wanted to end at 0.3, so that means I've got one more of these to do, doing Euler's method 3 times. Tangent line on a tangent line on a tangent line. So y of 0.3 is approximately, again, doing the tangent line, y1, but now I'm using my new point. So my new point, my new y is 1.42 plus m. Going back up here for my m, except what's my y again? 1.42. So 1 plus 1.42 becomes 2.42. Delta x is 0.1. So I have 1.42 plus, well, 0.1 times 2.42 is 0.242, which equals 1.662. So that is now my final answer, where I can say, okay, y of 0.3 is approximately 1.662. Or when x is 0.3, my y is approximately 1.662. There you go. All right, let's try another one. If any of this is going too fast, you guys can always pause, rewind, all of that. All right, so new example. Let's say our differential equation is, let's do x times y. The point that's given to you is y of 0 equals 2. And I want to figure out let's see. Let's say I want to figure out solve y of 1 in 2 steps. Well, this is interesting because what's missing? They told us where we started. They told us where they want us to end. They've told us the differential equation, but there's something that we're missing. And what we're missing is our delta x. Now, this is where you're going to have to do a little bit of math in a math class. Go figure. If I'm starting at 0 and going to 1, but I'm only doing it in 2 steps, that means what has to be true? What am I going to go by? Well, the only way to go from 0 to 1 in 2 steps is if I was going by 0.5, right? Go from 0 to 0.5, that's 1 step, and then from 0.5 to 1, that's 2 steps. So that means I'm only doing Euler's method twice. So the first one I'm solving for is y of 0.5 is going to be approximately, again, you're just doing your tangent line, y1, that's going to be 2, plus m, that's your derivative, that's your slope, that's over here, our differential equation. It says to do x times y. Well, in our case, it's 0 times 2. Well, that was easy. That's just 0. Times our delta x, our x minus x1, our change in x. Well, we already figured out we were going up by 0.5. Well, this is pretty easy. This is just going to be 2 plus 0, which is 2. So our 0.5 is approximately 2. Still have to do Euler's method again. If I do 0.5 plus 0.5, that gets me to y of 1. That's the one I want to solve for. This is it. I only had to do it twice. That's nice. Again, tangent line, y1. But which y's and x's am I using? I am now using the point I just solved for. My y1 is 2. It happens to be a coincidence that my two y1s are the same in this case. It's because I end up multiplying by 0. Don't get confused. You always use the previous point that you found. Plus m, x times y. Again, I'm using this x and this y now. It's the previous point. Well, 0.5 times 2, half of 2 is just 1. Times my x minus x1, that's always my delta x, that's going to be 0.5. So what do I have here? This ends up becoming 2 plus 0.5, which is 2.5. So my answer is saying, okay, at 1, my y is approximately 2.5. And there you go. Your homework. You're just doing the same type of step over and over and over again. Got it? So your homework, and this is assignment number 2. Today should be the 15th. Hopefully you guys are on track. Page 333. This is 7.1.2. You are going to do questions 51 through 58. Those are all the Euler's method ones. And then you're going to do some of those AP type standardized questions 69 through 74. All right, you guys should have plenty of time in class today to be working on this. Good luck.